Okay, Bismillah. Let us do more questions. Let us tackle question D. So how do we integrate? Okay, you can expand. So here we have to use a technique by simple U-substitution. Okay, let's do it together, y'all. Let's say you have to assign the U. Which is the U? Normally the U will lies inside a function. Okay, let's say the U is 5x plus 1. And then we need to differentiate because after this we need to replace all the x in terms of a u. Okay, so here u du dx is 5. So hence we can say that, what is dx? Dx is du over 5. Right, so then you would like to substitute, okay, this due question and make sure that you can or are able to change everything in terms of one variable. So for example, like this, okay, replacing that, the x is easily written there on 5, but up to this level you cannot yet integrate. Be sure you do not integrate up to that level yet. So you cannot integrate with two variables. So up to this level, you do need to find what is the x. But here you can see that we can actually find the x over here nicely. Okay, but yeah, I think after this it will be complicated. As we rearranging it, 5x is u minus 1. Okay, so let me rearrange it. 5x is u minus 1, so x is u minus 1 over 5. And as we replace everything in terms of a u minus 1, 1, 5. Here we have a radical u. Okay, not so bad. Okay, yes, you can actually integrate. U is u power half, and we have 1 on 5 du. Okay, so let's bring the constant in front. 5 times 5 is 25, and we cannot have a product rule. You need to expand. U power 1 multiplied by u power half, 1 plus half, so u power 3 on 2. Alright, okay, good. And here 1 times here, we get u power half u. Alright, so up to this level, can we integrate? Yes, you can, because there is only one variable. So let's integrate. Help me. So we integrate now. Okay. So check my work. Okay, 1 on 25. Write down back the constant, and here we have to use this basic formula x power r. So u 3 on 2 plus 1 plus 2 on 2, which is 5 over 2 over 5 over 2. Let's straight away flip here. 5 on 2 is actually 2 on 5. Okay, so let's rewrite it there. So it's actually 5 over 2. I flip it straight away. Okay, one more. Here we have u half plus 1, half plus 2 on 2, 3 on 2. So look here, yeah? Over 3 over 2. We flip it straight away. Right. And don't forget the c. But that is not our answer yet. We have to replace back the u in terms of x. So before that, let us factorize. Okay, here we have 2 and 2. So 2 on 25. And we can see we have a common term, u. Let's take out how to factorize. We take out the smaller power. In this case, the smaller power is the u power 3 on 2. So u power 3 on 2, right? And then we factorize. So here we have 2 is outside already. We take out the 25, so we have a remaining of 5 there. Okay, and here what is the power such that u times u power 3 on 2 is u power 5 on 2. Let's check. U 3 on 2 multiplied by u power, don't know, equivalent to u power 5 on 2. So this one must be 2 over 2. Okay. 3 on 2 plus 2 on 2 for the index, we get 5 on 2. 2 on 2 is actually u power 1. So we have like u power 1 on 5. Okay, good. And then second part, we have take out the 2, and then we have take out the u power 3 on 2. So we are left with 113 only. You can leave your answer like that. But yes, of course, you need to replace the U. Let's combine this, okay, so that our work will be nicer. And over here we have U power 3 radical square root. Let's combine it, okay. Because when we are to replace the U, our U is quite long there. So this times this 8. So we have 3U minus 5. Right. Now I am to replace my U as X. Okay, so we substitute. Okay, I combine it, replacing back the U as 5x plus 1 over there. Okay. And then we have this, and then you can see the 8, the 3 times 5 is 15, 3 times 1 is 3, 3 minus 5 is negative 2, 2 and 8 can cancel out, so 25 times 4 we get 100. So that will be the simplest version that you should give, right? What happened in your workbook, they leave it up to this level, okay, which you can as well, but this is, you have to simplify your work definitely, okay. Don't leave your answer hanging or not being simplified enough. So in your workbook, they put it up to this, okay, but I think you cannot leave your answer like this because you have a common factor which you need to factorize further, okay. So this should be the simplest form, alright. Okay, let us look at more example. Let us do question A. Alright, we start with having what would be the appropriate U. The U is normally lies in the denominator. The appropriate U normally lies inside the power. So here, let's choose the U inside function there, which is 5x squared plus 1. When you are choosing the U, make sure that your U here is easy to differentiate, like this one, okay? So we have 10x. Do not choose 5x squared plus 1 power 2. Okay, so we choose a simple, and then we are to substitute U in this. Okay, so over here we need to substitute everything in terms of the x before we are to differentiate. So we can see that the numerator value there is 10x dx. Okay, we're going to substitute this 10x dx in terms of our du, right? So as we substitute it, so now this question will become 10x dx, which is the u. I'm going to put it in at the back, and here this is 1 over u square, right? So we can rewrite it as u power negative 2. We're going to use this formula, so let's integrate, help me. So we have u power negative 2 plus 1, negative 1 over negative 1, and don't forget your c, right? This is similar to say it is negative 1 over u plus c. Okay. And don't leave your answer as u, you have to replace back into the variable given in the question. Okay. So the u is this u, 5x squared plus 1, and the constant of the integrand. Okay. Okay, next B. What will be the appropriate u? And again, choose the u inside the composite there, inside the function of power 7. So that will be the appropriate u. So let's choose u as 1 minus 1 on x. Do know that 1 on x is actually x power negative 1. So next we differentiate. Derivative of 1 is constant. Derivative of this is negative 1 times 1 is 1, x power negative 2. Okay. So this is 1 on x power 2. Alright, and we are to substitute. We notice that we need to substitute this 1 on x squared dx in terms of u. As you are to substitute, make sure that you substitute everything as your u. Okay, so let's substitute. So eventually this question now will become u power 7, and we have there 1 on x squared dx. 1 on x squared dx is the du. Alright, now it's easy for us to integrate. So using a formula there, integrating is u power 7 plus 1. Okay, 8 over 8. And replace back the u as x, which is, what was the x's now? Okay, let's put 1 on 8 up front. So we have 1 minus 1 on x, power 8. Don't forget your c. Okay, so there is the method on how to solve this integral. Alright. So by now we can see that you have to know how to differentiate. Let's recall back for those who forgot the basic formula of the derivative. If we have x power r, the derivative of 8 is rx power r minus 1. Okay, that's a formula that we will use for the derivative, and of course product rule, quotient rule, and so forth. Okay, next let's look at D. Okay, what would be the appropriate? Choose the most inside function to be our u, 10 minus x. Okay, so and then we are to substitute everything in terms of the u. Right, so derivative of a constant is a constant. Derivative of the negative one is negative x is negative 1. So hence we are to replace our x there as well. So x is actually, dx is actually negative du. Okay, dx that we need to replace is negative du. And as we substitute, alright, for example here, we have 3x there. Where to get that 3x? Okay, if you say that now I would like to differentiate and like this, okay, where the dx is negative of du, up to this level you cannot integrate. Why cannot? Why cannot? Yeah, because you have two variables, so you cannot integrate. Okay, so you have to replace this x as well. So where to get this x in terms of the u? So maybe we can get it from here. Okay, so help me. So from there we see that the u is 10 minus x. We need the x there. So let's rearrange in it. So x is actually 10 minus u. We rearrange. Okay, and we are to replace this x over there. So I'm going to erase this. You cannot integrate with two variables. Remember that, eh? Right, so let's erase it. Okay. So we have just now negative. Let's put it in front. Negative. And we are to replace this 3x. 3 is a constant. Let's put it in front. And the x is 10 minus u. And where is the du just now? Okay, negative du. Right, so now we can integrate. And before we are to integrate, you have to simplify this. This is similar to say as if you have 10 over square root u and minus u over square root u, and we are to integrate term by term with respect to du. Okay, before we integrate, let's simplify this further. Check my work. This is 10 of u power negative half. And over here, how to simplify? So whenever you have, as in algebra, whenever you have a power x over a power y, okay, so the indices we have to deduct. So in this case, we have u power 1 over u power half being the square root. So hence we get u half minus 1 minus half is power half. Okay, so we simplify first before we integrate. So we are not integrating yet, and we are to integrate term by term. Okay, so let us integrate this. Help me. So we have negative 3. Okay, integrate 10 u power here. So 10, and then we put down the u, negative half plus 1, which is half over half. Okay, and minus, one more time, integrate this, u power half plus 1, which is 3 on 2 over 3 on 2, and plus c. Okay, so let's simplify it before we replace the u as x. I'm going to erase this. I need some space. Right, so let's erase this as well. Right. So check my work. So this is like, if you simplify it, flip this half, it becomes 2. Okay, so 2 times 10 is 20. Square root u, and minus this thing again, 2 on 3. This u is actually u power 3 square root. And let's put the c at the very end. Right? And you can simplify this further. It becomes negative 60 of this thing, and 3 cancel out. Negative become plus of 2 u power 3, right? See. Alright. So before you finalize your answer, replace your u in terms of the x. Okay, so that is our answer for question D. Right? Okay, by now I hope that you can see, okay, the steps. Right, let us do one more. Okay, question A. So what will be the appropriate u? Okay, now, yeah. Okay. What will be the appropriate u? Should it be x minus 2, or should it be u as x plus 5? Very good. We should choose something that is hard. Okay, hard. We need to simplify it. So the appropriate u here in this case is x plus 5. Okay, so because we would like to simplify our integral in terms of u, and when we simplify, we would like to have something that is easy for us to integrate later on. So here I'm choosing u as x plus 5 only here. And we need to substitute everything there, dx. Okay, to get that dx, we need this du dx. Okay, so help me. So integrating x is 1, integrating constant is 0. So there we have dx that we need in terms of u. Du is actually dx. Alright, so let's substitute. Okay, as we substitute, we have x minus 2, and here we have u, and the x is du. So can we integrate? Yes, you cannot integrate. Why cannot? Right, you cannot integrate because you have 2 variables. Okay, there's still an x over there. You need to replace the x. Okay, so we cannot integrate. So let's replace it further. We need to replace this x. So where to get the x? We get it from this notation. So what is x? We're rearranging it. X is u minus 5. Okay, you need to replace it. Okay, so let's replace it further before we integrate. Okay, help me. Okay, one more time. X is u minus 5, and then we have x is u minus 5. So we have x is u minus 5, and there's a minus 2, and we replace x plus 5 as u squared. Right, before we integrate, now we can integrate nicely because we have one variable only. So, but yes, before you are to integrate, you might want to expand this, okay, so that it become a polynomial. Okay, wait, let me expand. Okay, so if my calculation is correct, we have u power 3 minus 7u squared. Okay, and now we have one variable u. So now we are ready to integrate. We're going to use this formula. So integrating u power 3 is u power 4 on 4. Integrating u squared, the 7, we put it outside. Integrating u squared is u power 3 on 3. And don't forget your c. Okay, and this is not yet our answer. We need to replace back the u in terms of x. So what is the u? The u is just now, okay, our x plus 2. Sorry, x plus 5. So we replace it back. Power 4, okay, power 3, and plus c. So that will be our final answer. Don't stop there. Make sure you do more exercises. Okay, so thank you for this part.